If you struggle with understanding the integrating factor method of solving first-order differential equations, then this video will make it really easy to understand where it comes from and how it works. So the first thing I'm going to go through is two differentiation techniques from Year 2 normal maths. These are the product rule and implicit differentiation. The product rule tells us that if we have two functions f of x and g of x multiplied together, and this is equal to something like y, then dy dx is equal to the first function left times the second function is differential, plus the first function is differential times the second function left. Then implicit differentiation is basically where you differentiate the whole function in terms of x, but if you have a y term and you need to differentiate it, but you can't rearrange the equation to get y as a subject, then you just differentiate y with respect to y, so that becomes 2y, then you instantly multiply by dy dx, and then the rest of the equation in terms of x, you just differentiate normally. So both of these will help us to understand what the integrating factor method is and where it comes from. So this is the general expression you need to get your function in terms of. So you have dy dx plus a function of x times y is equal to g of x. Now I've written it like this just to show you how we can actually go into the next step that you'll get from the integrating factor. So basically your integrating factor is equal to e to the power of integral of f of x dx. I'm going to get rid of this here. So this is f of x times y. So the integrating factor is equal to e to the integral of f of x dx. Now what you do is you multiply the whole equation by this integrating factor, and then you get something like this. So this f of x isn't the same as this one. This is just the general expression. So you have a function of x times dy dx plus the differential of that f of x times y is equal to g of x. Now this looks exactly like the product rule, but instead of g of x, we just have y. So y differentiates implicitly, as we saw earlier, to dy dx. So this is the first function left alone times the second function differentiated, so dy dx times 1. Then the second function is left alone, so y, times the first function differentiated, so f dash of x. So this is just a product rule. That means that we had some function f of x times y that differentiated to get this expression here. So then if you integrate both sides, you can calculate what that original expression was. So let's go through an example, because all of these can be quite confusing and it's better to understand with an example. So our example says dy dx plus 4y over x is equal to 6x minus 5. So first what we need to do is turn it into this expression here. So dy dx plus f of x times y is equal to g of x. So let's first split this up. So let's say that dy dx plus 4 over x times y is equal to 6x minus 5. So now our f of x is equal to 4 over x, and our g of x is 6x minus 5. Now using the integrating factor, so e to the power of integral of f of x, so we can say that our integrating factor is equal to e to the power of the integral of 4 over x dx, which is equal to e to the power of 4 times the integral of 1 over x dx, which is equal to e to the power of 4 ln x. But obviously we have a constant, so I'll add that on, so plus c, but this constant won't actually make a difference. You'll see why in a second. So this is basically just equal to, so e to the power of ln x is x, and then x to the power of 4 is going to be x to the power of 4, and then e to the, so we're doing plus c, so that's going to be e to the power of c times e to the power of 4 ln x. That's going to be some constant a times x to the power of 4. Now, if we multiply our whole expression by ax to the power of 4, we're going to have every term multiplied by a, and we can just divide it through again. So there's no point actually having this a here. So we never actually have to consider the constant when we integrate the integrating factor. So now we just multiply our whole expression by x to the power of 4. So now when we do that, we get x to the power of 4 times dy dx plus, so 4y over x times x power 4 is 4x cubed y is equal to 6x to the power of 5 minus 5x to the 4. Now what we can see is that here we've got the product rule. So if we take x to the power of 4 times y, if we leave the first function, differentiate the second one, we get this. Then if we differentiate the first function and leave the second, we get that. So this is the product rule. So this was our original function. So we can say that the differential of this function with respect to x is equal to 6x to the 5 minus 5x to the 4. Now what we do is we integrate both sides with respect to x. And since this is the integral of a differential, it just becomes the original function. So x to the 4y is equal to x to the power of 6 minus x to the power of 5 plus c. Dividing both sides by x to the power of 4, we get y is equal to x squared minus x plus c over x to the power of 4. And that's our answer. So the main thing you need to understand is just figuring out how to get your expression in some form of this up here. And then once you do, you can just take your f of x and then do e to the power of the integral of f of x. And then that's your integrating factor, which you then multiply the whole expression by to turn it into the product rule, which you can then go backwards from to get your original equation. So during my calculation, I went through this a bit quickly, but I'll break it down a bit more just in case you didn't understand. So when we had our integrating factor e to the power of the integral of 4 over x dx, I took the 4 out in front of the integral so that I had an easy integral 1 over x integrates to ln x. So that becomes e to the power of 4 times ln x plus c. That plus c, you can say times 4, but that's just going to be another constant, so you don't have to write 4c, it's just any constant c. And then this you can rewrite as e to the power of c times e to the power of ln x to the power of 4, using the rules of powers. So e to the power of ln x to the power of 4 is equal to e to the power of 4 times ln x, which we had over here. Now e to the power of ln x, so that's just saying what power do you put on x, what power do you put on e, to get x. If you put e to that power, you'll just get x. So that's x to the power of 4. E to the power of c is just another constant, so that you can call a. And then again, if you multiply your whole equation by ax to the power of 4, all the a terms can just cancel if you divide through by a. And that's why you don't actually have to include your constant of integration when you do the integrating factor.